Hi, we're on United Airlines Flight 893 to Seoul, Korea. People from all over the world come to Seoul to experience Korean art, history, culture, food, and to do business with the Koreans. But we're here today to do some carpool chemistry. Today, we're going to learn how to calculate the density of a gas. Let's say you have a gas, such as butane, the same gas that's found in your butane lighters for your barbecue. Its formula is C4H10. Let's say you're at sea level, 1 atmospheric pressure, and a little bit over room temperature, about 25 degrees Celsius. A nice day for a barbecue. Well, the first thing you want to do, of course, is you want to write down given. So you organize what you have available to you and what you need to find. So we're given pressure is equal to 1.00 atmospheres. Temperature is equal to 25 degrees Celsius. We know that we're dealing with gases, so we automatically add 273 to it to get 298 degrees Kelvin. We also know that the formula is C4H10. That's very important. Then, of course, we want to find the density. As we know from previous chapters, density is the concentration of that. That is, how compact are those gas particles in this gas. We know that density, the formula for density, is equal to mass divided by volume. Would you agree that if we knew the mass of the gas and if we knew the volume of the gas, we'd simply divide the two in order to get density? But do we know the mass of the gas? No, we don't. But do we have something that'll help us to find the mass of the gas? What we do know is molar mass, and we do know that density does not depend on the amount that you have. The density of a small sample of gas at a certain pressure and temperature will be the same as the density of a large sample of gas at a certain pressure and temperature. So for convenience sake, we're going to assume a 1 mole sample. If we assume a 1 mole sample, the mass of that sample is simply the molar mass of C4H10. To calculate the molar mass, as we've done many times before, carbon 4 times 4 moles times 12.01 grams per mole is 48.04 grams. The hydrogen portion is 10 moles times 1.01 grams per mole is equal to 10.10 grams. And this would be carbon, this would be hydrogen. You add them together to get 58.14 grams of C4H10. So that's the mass. Later on, we're going to put that right into here. How about the volume? What is the volume of the gas equal to? Well, we don't know the volume, but we do know its pressure. We do know its temperature, and now we know that there's 1 mole of that gas, and so we could use the formula PV is equal to nRT to find the volume, because we can check off the items that we have available to us. Pressure. We don't know the volume. Let's put a question mark there. We now know the number of moles because we assumed a 1 mole sample. We do know R since it's a constant, and we do know the temperature. So let's solve for volume. To get volume all by itself, we want to divide the left side by P. If we divide the left side by P, in order to keep things equal, we also need to divide the right side by P. The P's cancel out, leaving us with volume is equal to nRT over P. We can now fill in our unknowns. N is 1 mole. R is 0.0821 liters atmospheres over mole degrees Kelvin. T from up over here is 298 degrees Kelvin, and all of that is over P, our pressure, clocking in at 1 atmosphere. Crunch this on your calculator, you come out to a value of 1 times 0.0821 times 298 divided by 1 is equal to 24.47 liters. We now take this value and we put it in right over here. For volume, coming back up to our original equation, density is equal to mass over volume. We have 58.14 grams divided by 24.47 liters. And so our density will be 58.14 divided by 24.47 equals 2.38 grams per liter. And that's how you calculate the density of a gas. From United Airlines Flight 893 to Seoul, Korea, this is Carpool Chemistry.